So today's topic will be mutation testing. Just a quick show of hands. Has anyone did mutation testing, regardless of the language? Does anyone know what it's all about? Good. Okay, that's good. So, I mean, we all do TDD, and we all believe that our tests are awesome, right? Have you ever felt like, has it ever happened to you, like you changed a piece of your code, but no tests break? No tests broke? It's kind of, maybe there's something here that's not quite right. So anyway, the tests are meant to guard our code against bugs, but who guards the tests? Well, how can we measure the quality of our tests? Anyone other than mutation testing, but we'll get to that later. What is the typical measure of test quality that we have out there? Yeah, that's right, code coverage. The code coverage is better than nothing. At least you know that some code is being tested. The issue with code coverage is that usually it's hard to see when we only have partial test coverage. So you might cover the line, the source line, but you might not be covering all the branches. And let's enter mutation testing. So the goal of mutation testing is it changes the original source code. The tests are exactly the same, but it changes the original source code in a well-defined way. So there will be several mutators. The concept of mutation is it changes a particular pattern of code, and then it runs the test suite again. And if no tests break, then that mutation has survived, and that indicates a problem with your test suite. So a couple of examples of different mutations. I mean, this is pretty much common to all the mutation testing tools out there. I will be focusing my demonstration later on PIT, which is for the JVM, but you will find exactly the same types of mutations on JavaScript, Scala, etc. So there we have conditional operators. So whenever it finds this operator, regardless of where in the code, it will change to the other version. So just add an equal. If it had an equal, it just removes it, and so on. This is a conditional boundary. Negate conditionals, just inversing the meaning. Okay. Remove the conditional altogether. So if you have something, you can have two mutations, just forcing the branch always to be false or forcing the branch always to be true, regardless of what you have here. If you have math operations, then they can be mutated too. So when you have a plus, it becomes a minus, division, multiplication, so on. Increments and decrements, they become the opposite. Invert negative, so if you're returning a minus I, it removes the minus. Whenever you have constants in your code, so it just replaces those values by something else. Whenever you're returning values, so this is different from the previous one. This one is just for constants. The return values is when you're actually returning the value, which is a different use case. But it does pretty much the similar thing. Void method calls. This is interesting, especially when you're dealing with really bad code that relies on side effects. I know the plus grade folks will probably be familiar with lots of those. So let's assume we have a function that doesn't return anything and does something evil with side effects. And we call that function on our source code. So the mutation will be just don't call it and see what happens. If no test fails. We've mentioned the mutations on return values for primitive types, but there are also built-in mutations for collections and optionals. the usual suspects. If you have a method that returns a string, it just goes there and replaces the code to just return an empty string. So what does it look like in practice and how this is implemented? I mean, it depends on the programming language, it depends on the tool, but for Pit, the framework I'm going to demo right now, it actually does something very smart. So it gathers all the class files from the test code and the source code, the original source code, and performs bytecode mutation. So you don't have to recompile the code over and over again, and that's what makes it pretty fast compared to how mutation testing used to be done in the past. So because it would actually force you to recompile the code every single time for every single mutation. And if you've seen at the possible mutators that we have, the number of possible mutations is quite large. So let's look at a demo. So I've picked up a couple of libraries that I think we pretty much have used, at least if you're working with Java code, at least directly or indirectly you've used those probably. That's Jackson for parsing JSON, and Commons Lang, which is pretty used for all sorts of libraries like Spring. Spring uses Commons Lang, and added the mutation testing configuration on the build. It's pretty trivial. You don't have to do anything fancy on your code setup. You just have a dependency, set the number of threads and the packages that you want to insert mutations into, and that's all you have to do. And then hang on. And then you just run this goal, and it will generate a pretty HTML report with a mutation report. Something that's very important, because Pit relies on precompiled code. Go ahead.
Is it deterministic? If I run twice, I always have the same results?
Yes. So it returns all the mutations in order. You can enable and disable specific mutations. But of course, it might not be deterministic if your code is not deterministic. So if you have some sort of random behavior there, then all bets are off. But you have to compile the code first. It doesn't compile the goal unless you set up Maven and set up a specific goal that has a specific requirement on the code being compiled. It doesn't do that by itself. And let's look at an example report. So inside of your target folder, you will have a Pit reports, and in there, the timestamp, and where we are. So here is the traditional code coverage, and this is the mutation coverage. So the mutation coverage is always less or equal than the code coverage, because if the code is not covered by any test, doing a mutation won't do you any good, right? So let's look at a couple of examples here. Let's figure out one. Where is the significant differences? JSON parser.
So this doesn't say if the tests fail or not. It's about coverage.
No, it says that it mutated the code and tests failed to detect the mutation.
Which tests?
The tests that come with the library. So you have your own test suite, right? So the point of mutation testing is it changes the original source code, and if no test detects the mutation, it means that your tests are not doing what they should, or they're not being assertive enough.
You run the unit tests, and then you mutate and run the unit tests again,
and so on. You don't touch the tests. That's the critical concept. The tests don't get mutations, only the original source code.
So
Yeah, that's the whole point. Is how do we watch the watchman, right?
Or you can that code too, by chance.
What?
If you have that code, you can find it with this tool.
Yeah. Well, but that code will also be reported by a regular code coverage tool. I think this does something even better, which is, okay, you might have 100% coverage and the line coverage, but you might not be covering all the branches or all the possible, or even if you're covering all the branches that you expected, you might not be covering changes in the source code.
Might have a bug in test.
Yeah, also.
And you might cover all the codes, messing up all the conditions, so you can have ifs and stuff like that with multiple conditions. And you always enter in one.
Okay, here we are. So this is the original, the report contains the original code, and if a mutation survived, it will tell you what was the mutation that survived, if with a number, with a counter of the mutations that survived. So here we have 1, and if you over it said, well, I returned something else, and the test didn't fail. No tests failed, and the method is always returning null. So who knows what's going on here? Here, 2 mutations survived. So we have a conditional, and it just negated that, and no tests failed. I mean, and it goes on and on and on and on. If mutations get killed, it will tell you. So, for example, this is okay. So it performed mutations, but the mutations got killed by the tests. So that you have a green bar. Let's find some. Now this is the return value again. Oh, this is whenever there's a long sequence of ifs, there's always usually something wrong. So negated. Actually, these ones are, I think there's no coverage at all. Here we are. So what survived here? Inverting the conditional actually got caught by some tests, but replacing the return value did not. Let's look at another library. Oh, here we have a good example. So 100% line coverage. However, the mutations, and what I think is a pretty serious one. You have like critical methods like hash code with poor coverage. So, and here is just both mutations survived. So inverting the conditionals and replacing the exclusive OR operator with something else, with AND. So at the end, you always have a report of all the mutators that were applied. Not all run by default. And you can also exclude some mutators if you don't want particular mutators. Things that might happen in the code, by mutating the code might enter an infinite loop. So the tooling won't report that as a test failure because the code might just be invalid. It just times out. So whenever a mutation times out, that's excluded from the report. It might generate invalid code. And in that case, it's also excluded. It also might generate what they call equivalent mutations. So let's imagine a scenario where we have probably outside of the camera. Okay, cameraman is there. So let's imagine that we have a bit of code like this, and we have an if. So changing this won't make a difference because I will always be bigger than 2. So and the tooling detects that and says, well, this is an equivalent mutation to the code, so let's not bother with that. It doesn't run them.
So you have greater, I flip and saying it's greater to become.
Yeah. So you have the conditionals where it's just becomes where greater or equal becomes just greater. You have the invert, like if you have greater it becomes less. You have the just negating completely the logic and hard coding the if decision to a true or false value, so that block of code doesn't get run. Well, and all of the other ones. So I think mutation testing should be more used. It's fairly easy to integrate with the code base. There are a couple of caveats, and sometimes the tooling the tooling library that's being used for mutation testing is a bit fiddly on its requirements. So, for example, Pit forces you to have at least JUnit 4, a dependency on JUnit 4, which is probably not a big deal because pretty much everyone uses JUnit 4, but it doesn't support JUnit 5 yet, for example. But if you're picking up an old library, say I tried this with Joe the time, but it actually uses JUnit 3 on testing. So you can, I mean, you'll need to do a bit of work. But these are more caveats related to this particular tooling. And in JavaScript land, you have a lib called Striker, which is pretty good too. There's also for Scala, stuff like that. So I think we should, make mutation testing as part of our day-to-day coding pipelines. Probably not a good idea to have it in the default run, because this will take a while to run. Even though the PID is pretty much optimized, it's still generating thousands and thousands of test runs. So if your regular test suite takes a minute, you can forget it, because it will take probably several hours to perform mutation tests. So it's probably something that is worthwhile doing as part of a separate build step, but you should be doing nonetheless, especially as it comes for free. So when it comes for free. Questions?
Is it possible to run something like this for closure, like which is on top of the JVM?
I guess so. The way that Pit works is it actually works on the bytecode. It doesn't work on the source code. So as long as you have the source mappings on the bytecode done correctly, then it should work too. Because Clojure will have its own conditionals. I think Pit will pretty much work for any JVM related language as long as the source maps are in the source on the class files. I think the tricky bit is if the actual source that gets compiled doesn't actually accurately map to the original source, if it's got transpiled in some way. So, for example, in Scala, the Java code that gets compiled might be a bit different from your original source code, because it generates all sorts of intermediate classes and lambdas and stuff. So it might be harder for you to make sense of what's going on. But it will work. Anything else? So let's do more of this.
I was looking for C# implementation. So if a test suite takes like 5 minutes, this will become possible?
Mm,
It depends on the...
Running on the side on the server.
yeah, that's what I was saying. I think it's
It takes 12 hours.
So what?
That's feedback, I will ignore it.
What?
You can pick a subset of mutates as well.
You don't wait for your commit. It's something you
well,
take a look.
this is something that you have running on the side.
I know, but there's 20 commits a day, right? And I do a nightly build with mutation. It will only do the latest commit. But it will give me feedback 12 hours after. I'm talking about 12 hours, probably it won't take 12 hours.
It might take more. I mean, but the thing is, you'll get feedback, and I think it boils down to how much value you put in your tests, right? If you care, you will use it. If you don't care, probably I wouldn't be working here. Yeah.
So it's not telling your production code is broken or it's bad. It's telling you your tests can be better. So you
Yeah.
can incrementally improve the tests of features.
That's right.
Because the features are.
We know how it works. If it takes too long, you won't look at it.
But
Yeah, but this can be run
Well,
every other day, even once a week, and you get a report on the quality of your tests, and you can
Would
improve.
you run your unit test once a week?
But that's also, the unit tests run the quality of the code.
For me,
And-
unit tests are first citizen in my code.
Yeah, and so
So
they
I
should
should have
run.
immediate feedback.
Well,
But this is not unit tests. This will
you
run.
could start not having tests with that run 5 minutes, but
yeah, yeah, that's
it should be on the
I
seconds.
admit, this is better than nothing. But
Seconds, but still, it's
well. Look at the
a lot of tests to
look
run.
look
You want to be
look at the alternative. Ignoring this, it means like you don't care. I mean, if you don't care, you don't care, right? There's nothing we can do about that. But I think, I mean, even in pretty much well-established libraries in my own code, I've seen problems because it's easier to get overconfident because, well, I mean, we all do TDD, but sometimes we get sloppy. I mean, if people followed like 100% perfect TDD, probably wouldn't need this. But of course, we are all humans. We all bend the rules now and then, and things fall through the cracks. Another good thing is combining this with property-based testing. And that, if you combine mutation testing with property-based testing, probably you have a really good combination.
But there's not much way to go around the math. I mean, if your test suite takes 10 seconds to run, how many times did it iterate?
So
1,000 times?
it generates all the mutations for the code blocks. So
How many?
let me give you an example for Jackson and Commons Lang. The unit tests run on this laptop in like 10 seconds, and the mutation tests with 4 threads took something like 20 minutes. I mean, no, I mean it's not a big library. It has several classes, but it's not a big library. I would call something like Spring Boot or Spring. I mean, it's like that's a big library, but this is like a tiny thing. Jackson is just the JSON parser.
You get a factor of 10 seconds for that.
So-
20
so-
minutes. But there's a lot of tests run, so there's no way around it. It's not a immediate feedback.
But-
never been immediate feedback.
But let's say if you have something critical like hash code method, like that hash code method that's used for inserting stuff into and storing that in an hash table and fetching it in containers. If you don't have appropriate tests for that, that's something I would like to know. Maybe what you can do is that, okay, there are areas of the code that are more critical than others. There are areas of the code that I care more about, and then you can probably just select a subset of your code on the tool configuration and just mutate that. Probably.
Okay, so you can do that, just apply on the thing you're working on.
Yep.
And then reduces substantially the work.
Continuous delivery or big pipelines, you can just try to parallelize, like take a few subsets of the code and test one worker, and the other worker will test the rest, and etc.
You can.
Parallel increase the time.
or increase the number of threads. So you actually by default, because I think this is a conservative setting that the library has, by default it only runs one thread. The reason it being is your test might not be thread safe.
It would work like our microservices are not that big, so working on a feature for a while, for the end of the day, running the 20 minutes before pushing, just as a sanity check, see if there's not any hole there.
Yeah,
You
again,
can see it doing it.
again, the key point is your code might be 100% correct. I think if you fail mutation tests, it just means that your tests are not good enough.
You can introduce a bug later and the test with the bug.
Yeah.
Yeah,
This is a safeguard for tests.
Quality check for tests.
yeah, and this is the only way. Okay. So, any questions from the remote audience? If there's any,
No, we don't use tests.
we don't use tests. I figured. Lina, Rafael?
I was asking if you have it for shell script. You have it for Bash.
No, not from my side.
Okay.
Thanks, Miguel.
Bye.
For now.
Bye. Terminating. Done.